Today I am going to take a lecture of Discrete Mathematics chapter number 3rd, and the topic is the partial order set or partial order relation. So we have already seen in our previous lecture what is the process for the Hazer diagram. So our next topic is maximal element and minimal element. This is very interesting topic according to the Hazer diagram. Okay. So you have already seen in our previous lecture. So what is the process for finding the Hazer diagram and why we use the Hazer diagram? Okay, and the Hazer diagram, if a partial order relation given, then we use the Hazer diagram. Okay, if your partial order relation is not given, then first you check here your relation is in the partial order coset or not. If yes, then you draw the Hazer diagram. Otherwise, your partial order relation is not given, so we don't here draw the Hazer diagram. Okay. So first one is the maximal element and the minimal element. This is very important and the interesting point according to Hazer diagram. Okay. So maximal element, that means what? If in a coset. So listen carefully. Coset, that means partial order relation already satisfied. Okay. So if in a coset an element is not related to any other element. Okay, so you have already seen in our previous lecture, if we draw the Hazer diagram, so bottom to top, we draw the Hazer diagram, bottom to top. So every element, so lower element, that is the bottom element is always related to every element. Okay, but the top element is not related to every element. That means what here? D related to B, but B not related to D. Why? Because of this is the anti-symmetric property. Okay, so we draw the Hazer diagram always bottom to top. Okay, so here maximal element, that means what? If in a coset an element is not related to any other element, that means this element related to B related to A, B related to C, but A not related to B and C not related to B. Okay, that means A and C is what? Is a maximal element. Okay, so in any Hazer diagram, more than one maximal elements are present. Okay. Next one is the minimal element. So what do you mean by the minimal element? Minimal element, that means if in a coset no element is related to an element. No element is related to an element. That means what? Here A and C related to B. Okay, that means B related to A and B related to C. D related to B. But here the bottom element, so no element is related to D. Okay, so this is your minimal element, and in any Hazer diagram, one or more than one minimal elements are present. Okay, so with the help of maximal element, that means what? That means one point is very clear according to these two definition. Maximal element, that means top of the Hazer diagram, and minimal element, that means bottom of the Hazer diagram. Okay, so here one or more than one maximal elements are present in the Hazer diagram, and one or more than one minimal elements are present in the Hazer diagram. Okay, so let's start the first diagram. Here we are given in A, C, B and D, four vertex. Okay, this is the Hazer diagram. Okay, so here D related to B, but B not related to D. Okay, B related to A, but A not related to B, and B related to C. So always it's starting from bottom to top. Okay, so in this Hazer diagram, the maximal element is what? Maximal element, that means what? An element is not related to any other element. So here A and C not related to any other element. That means here maximal element is what? A and C. Got it? Minimal element, that means what? Minimal element, that means no element is related to an element. That means here this is the bottom element and no other element is related your minimal element is what? Minimal element is D. Okay, this is the first example. Next example. Here we are given in the A, C, D, E and F. Okay, and here we find out again the maximal element and the minimal element. So what is the definition of the maximal element? So always keep in mind in 2 points, maximal element always top of the Hazer diagram and minimal element is always present in the bottom of the Hazer diagram. First point. Second point is in the maximal element, an element is not related to any other element. Got it? So here A related to C related to E, but E not related to any other element. Okay. Here D related to E, but E not related to D. That means always you draw the Hazer diagram bottom to top. So upwards you consider here. So here E not related to any other element. So your maximal element is E, comma. Here F. D related to F, but F not related to D. So F is also the maximal element. Okay. Next one is the minimal element. So minimal element, that means what? No element is related to an element. Okay, so here minimal element is always in the bottom side. So here A, no element is related to this A, no element is related to this B. So minimal element is what? A, B, and here this is the F. Okay, so F is the maximal element and B is related to F. So this E and F is maximal element and this A and B your minimal element. So don't be confused here because of here F is not related to any other elements is not related to F. So don't be confused here. This is any element and element is not related to any other element. So this is your maximal element and minimal is what? No element is related to an element. Okay, next one is third. This is very interesting Hazer diagram. Why? Because of here A, F, I, H, G, C, E, D and D. Here we are given in this type of the vertex. Okay, so maximal element is what? So maximal element is always top of the Hazer diagram, but in this diagram always you keep in mind an element is not related to any element, then those elements are the maximal element. Okay, so here obviously B and D not related to any other element. So maximal element is what? B comma D. But here see carefully, here G and I. G and I is not related to any other element. Okay, so G and I is not related. Okay, in upper side. So G and I is also the maximal element. Got it? Next one is the minimal element. So minimal element is what? Minimal element is no element is related to an element. So here obviously F and H. Here F and H no element is related to any element. So F and H minimal element. Okay, but here C not related to, no element is related to and this element C. So your minimal element is what? S, H, C. And the maximal element is what? B, D, G and I. Okay, so this is very important point of the maximal element and minimal element. Our next topic is maximum element and minimum element. So what is the difference? Maximal, maximum, minimal and minimum. So maximal element, that means according to your Hazer diagram, one or more than one maximal elements are present in the Hazer diagram. But maximum element is a unique element. Okay, so maximum element, that means what? every element is related to this element. Okay, so maximum element is always unique and minimum element is always unique. But maximal and minimal elements are always one or more than one in present in your as a diagram. Okay, so our next topic is the maximum element and minimum element. Our next topic is the maximum element and the minimum element. So maximum element, that means what? Top of the Hazer diagram, and minimal element, that means what? Bottom of the Hazer diagram. But maximal element, that means have different elements related to those elements, but this element is not related to any other element. So this is the maximal, and minimal, that means the bottom of the elements. Okay, so here next one is the maximum element. So maximum and the minimum elements always unique. That means what? If it is maximal elements and every element is related to it. That means the maximum element is a maximal element and every element is related to it. This is the maximum element. Minimum element, that means what? If it is minimal, that means for finding the maximum and the minimum element, you have the maximal and minimal element. Listen carefully, don't be confused here. So minimum element, that means what? The bottom of the Hazer diagram. So minimum element is always in the minimal element. That means if it is minimal and it is related to every element in percent, that means minimum element is related to every element, and maximum element, that means what? Every element related to those elements. Okay, so this is the example of the finding the maximum and the minimum element. Okay, so here D and E both are maximal element. Okay, D and E both are maximal element. So maximal element D and E. Okay, but the maximum element is what? Maximum element, that is what? Every element is related to it. So A related to C and C related to D. So obviously A related to D, B related to C, C related to D, obviously related to D. A, B related to C and C related to E. So D and E maximal element. But if we choose here the D is a maximum element, so A, B, C related to D, but E is not related to D. Why? Because of if E related to D, so you downwards, but this is not valid according to your Hazer diagram, because of Hazer diagram is always bottom to top, and C related to E not related to C, because of this is the anti-symmetric property. So ABC related to D, but E not related to D. That means here maximum element is what? There is no maximum element. Okay. Here the minimal element. So minimal element, that means here the minimal element is equal to what? A and B. Okay, A and B. But minimum element, that means what? It is related to every element. Okay, but here B not related to A or A not related to B. So here no minimum element. Okay, that means according to this here, the maximum element here not present in the maximum element and not present here the minimum element. Maximal element and the minimal elements are present because the maximum and minimal element is always unique. Okay, this is the next example. So here A, B, C, D, E, F. Okay, so here the maximal element. So maximal element is equal to E. Okay, and maximum element, that means what? Maximum element is always unique. Okay, so maximum element, that means what? A related to B, C, D, E. C related to E and F related to E. So E is unique and every element is related to this element. So maximum element is E. Okay, minimal element. So minimal element is bottom of the as a diagram. So this is the A. Okay, but minimum element, that means what? Minimum element is always unique, and this element is related to every element. So minimum element is equal to B, A related to B, C, D, F and E. So here minimum element is A. Got it? So maximum element and minimum element is always unique. Don't be confused here. In any hazard diagram, the maximal element and the minimal elements are present in one or more than one. Okay, but maximum and the minimum elements are always unique. Okay, so maximum elements, that means every element is related to this elements, and minimal elements, that means what? It is related to every element. Okay, so this is very easy example and very interesting topic: maximal, minimal element, and maximum and the minimum element. Our next topic is the lower bound, upper bound, and greatest lower bound and the least upper bound. Okay, so I will continue this topic in our next lecture. Thank you for watching this video.